Question number 19. What mass in kilograms of ammonia will be formed when 7.22 kilograms of hydrogen and 43.5 kilograms of nitrogen are added according to the following balanced chemical equation? 3 hydrogens plus 1 nitrogen reacts and forms 2 ammonias. Cool. Okay, so when you see a problem like this, when they give you 2 mole numbers or 2 masses of of reactants, like H2 and N2, it's going to be a limiting reagent problem. And the concept behind limiting reagent problems are basically that they're going to give you too much of one, and so the amount of product that's able to form is the one that corresponds to the reactant that you have just enough of. So suppose you have, for example, suppose you had 4 moles of hydrogen for this reaction and 1 mole of nitrogen. Well, you can see in this reaction that for every 1 mole of nitrogen, you need 3 of hydrogen. So here you're given 1 mole of nitrogen and 4 of hydrogen, but this by the time all of this nitrogen reacts, you're only going to have used 3 moles of hydrogen. So you have excess hydrogen, 1 mole excess to be exact. So the amount of nitrogen that forms, or ammonia that forms, is going to correspond to the amount of nitrogen that you have. So in a limiting reagent problem, what you want to do is you want to see how much of the product each one of your reactants is going to form. So let's start with, they gave you 7.22 kilograms of hydrogen. Okay? So the first thing I'm going to do is put that in grams. So times 1,000 grams per 1 kilogram. So the kilograms cancel. And now the molar mass of, I'm going to convert this to moles. So 1 mole of hydrogen for every, the molar mass of that is 2.016 grams of hydrogen. So the grams of hydrogen are going to cancel out, and you're left with moles of hydrogen. So now you can convert this to moles of ammonia. So 2 moles of ammonia for every 3 moles of hydrogen. And you can just get that from the chemical equation. 2 moles of nitrogen for every 3 moles of hydrogen. So the moles of hydrogen cancel out. Okay, so this is going to give you just grab my calculator real quick. This is going to give you 7.22 times 1,000 divided by 2.016 times 2 over 3 gives you 2,387.566 moles of ammonia. Okay? So now let's check out the other reagent. So they give you 43.5 kilograms of nitrogen. So same thing, convert this to grams. Kilograms cancel out. So now the mass of nitrogen is 1 mole of nitrogen per 14 grams of nitrogen. So the grams of nitrogen cancel out. Right? And then according to your chemical equation, you get 2 moles of ammonia for every 1 mole of nitrogen. 2 to 1. So the moles of nitrogen are going to cancel. And this gives you 43.5 times 1,000 divided by 14 times 2. It gives you 6,214.285 moles of ammonia. So this amount of hydrogen will give you 2,387 moles of ammonia, and this amount of nitrogen is enough to give you 6,214 moles of ammonia. So this is the amount that's actually going to be made, because there's only enough hydrogen to make that much. So after this much ammonia is going to be made, the process is going to stop. So you're not going to get this. Whoa. Okay, so that's the number of moles of ammonia that you're going to get. So the last thing to do is to convert that to mass. So we have 2,387.566 moles of NH3 times, use your periodic table to get the molar mass, but it's 14 plus 8 times 3. So it's 17.024 grams per mole. So the moles cancel out, times 2,387.566 is 4645.92 grams of ammonia. So your answers on your test are all in kilograms. So if you divide that by 1,000, it's 40.64 kilograms. Okay? And that's closest to answer 2 on your test. It says 40.67 kilograms.